Want to shut the door, please? Okay, how's everyone today? We're going to do exercise 17, problem set 10, exercise 17, okay? I'll read it to you slowly, all right? And then we'll take it from there, all right? Easy? It says, Allegra's favorite ride at the Barrel of Fun amusement park is the flying umbrella. Allegra's favorite ride at the Barrel of Fun amusement park is called the flying umbrella. The operator activates the ride by applying a force of 72 newtons. So the force applied is 72 newtons, okay? The force applied is 72 newtons. And he is applying that to a piston that is 3 centimeters across. Okay, so therefore, if it's 3 centimeters across, that's the area, radius, or diameter? Diameter, okay? So the diameter equals 3 centimeters, which equals, in terms of meters, equals what? 0.03 meters, okay? 0.03 meters. Clear so far? You with me? So far so good? Okay, now. This 3 centimeter wide cylinder, we call the piston, it holds a 20,000 Newton ride off the ground. What is the diameter of the piston that holds the ride? Okay, clear? So this is the Barrel of Fun amusement park. This is the flying umbrella. And in order to lift 20,000 newtons, we are going to apply a force of 72 newtons to a piston that's 3 centimeters wide, correct? So what's the diameter of the piston that is actually supporting the rod? Okay, now let me ask you a few things. You ready? But first, the bell. Let me ask you a question. I'm going to do an experiment with you, okay? I'm going to do an experiment with you. And the experiment is I turn a switch, okay? I turn a switch, and that's action A. I turn a switch, correct? And B is the lights come on, right? That's another action. The lights are coming on, correct? Correct? Lights come on. Okay? Yes? 2 actions. I flick a switch, the light comes on, correct? There are 2 variables there, correct? What are the 2 variables? Flicking the switch, that's variable A, action. Correct? And then there is a action B, the light's coming on, then that's going to be variable B, correct? Now, this is the question. Which one is independent and which one is dependent? Which variable? We have 2 variables, okay? We have A and B, right? 2 variables. A. Is A independent or dependent?
Independent.
A is what?
Independent.
Independent. A is independent. Therefore, what's B?
Dependent.
Dependent. Variable B is dependent. Correct? Easy? Yes or no? You get that? Now, what's another word for independent? What's another word for independent relative to the work we're doing here? Wouldn't this be the input? Wouldn't the independent be the input? Correct? And what's the dependent variable therefore? It's the output. You see that? Input, output. Yes? Yes? Okay, now, let me erase this for just a second. Okay, and I want to define two things. Input, output. Define for me, therefore, the input. Define that word for me. The input is what the scientist touches. Touches directly. Correct? Yes? Correct? Yes? Correct? Yes? It is the what? It is it's the action, correct? It's the action. And what is output? Output is caused by input. Correct? Caused by input. It's the reaction. Correct? It is the reaction. Yes? So I'm applying a force to a piston. I'm applying 72 newtons to that piston. Is that Fi and Ai or Fo and Ao? It's Fi-Ai. You get it? So I'm going to erase this. That's the end of our little experiment. Okay? Yes? Can I erase all this? And I'll just rewrite it neatly. Is that okay? Yeah. All right? So now we know we have four things. Fi, Fo, Ai, Ao. Okay? Now we could shorten this up a little bit by just using the Greek letter pi, just a hint. But I'm not going to do that. I want to do this the long way. Do this the hard way, okay? Easy? Yes? Yes? Okay. So, we want to say, so what's the input? What's the force input? 72 newtons. The operator, the engineer, the scientist, the big guy, the big girl, right? That's what they're touching. So that's Fi. What's Ai? Pi 0.015 squared, correct? Right? Pi times 0.015. Wait a second. Why did I just write 0.015? Didn't it say 0.03? Yeah. But what's 0.015? Why did I do that?
The radius.
The radius, because they give you the diameter. Let me read you the verbiage. It says, the operator activates the rod by applying a force of 72 newtons to a 3 centimeter wide cylindrical piston. Right? So the piston is 3 centimeters. That's the piston. So that's D. Right? Half of D, correct? Right? All right, are we given anything else? What's FO? What's the result of all this? What's the job? Remember when we did machines, I actually called it the job. What's the job? 20,000 newtons? Are you reading the same problem I'm reading, or are you reading like a translation into Uzbekistani or something?
It says which was the 20,000.
20,000 newtons, right?
Yeah.
Good? You know, because something is always lost in the translation, okay? All right?
Ah, I get it.
He finally gets it. He didn't think. He's so serious. He's such a serious student. Mickey is a serious student. When I think of student, when I think of serious student, I think of Mickey. Okay? See how quickly I did that? Okay, now. So, could you give me a number? What's pi 0.015 squared? Give me a few sig figs here so we don't have sig fig error. Yes? 0.071. Is that right?
No.
No, that's not right, is it? 3.14, or just put in pi into your calculator, times 0.015 squared. 0.0007. Okay, Ashley, Alexis, I'm curious as to how you got that. Okay? If this were banking, you would be found guilty of white-collar crime. Okay? How'd you get it? She's laughing. She thinks that's funny. I'm not amused, trust me. What do you got? 0.0007 what? Pounds? Kilograms? Meters? I'm not asking you. I'm not asking you. I'll ask somebody else. Anybody? Area? I look bad. I look bad. Now you look bad to the entire world. I want you to know that.
I was just about to say
I want you to know that. This is forever. You can look at this film when you're 80 years old and say, I didn't know area was meters squared. This is forever, okay? I want you to know that. All right, now, so I need to know that area, but I'm really looking for, what am I looking for exactly? Doesn't it say, this is what I'm looking for, the diameter of the piston. Isn't that what I'm looking for? Can you see that on the thing?
Yeah.
Okay. Yes? Okay, so what's the equation for Pascal's principle? Isn't it FO AO equals FI AI, right? Yes? So that's going to be 20,000 over AO equals 72 over 0.0007, right? I left off the unit labels. Is that okay? Okay? They're terrible with unit labels, but we're working, we're trying. Anybody? Anybody have it? What is 72? What is 20,000 times 0.0007 divided by 72? Small number.
0.194.
0.194. Is that what you get? 0.194. So the area equals 0.194 meters squared. Is that the answer? Is that the answer? That's not the area. That's not the answer. Okay? So what's the answer? Doesn't this equal what? Doesn't it equal pi r squared? Doesn't it? So what are you going to do? You're going to divide by pi, correct?
Yeah.
You're going to divide by pi. You divide by pi, and you're going to take the square root, correct?
Yeah.
Do I have to do that? Do I have to write that on the board? You can do that? Do you understand my words?
Yeah.
Yes? So, they're thinking.
0.249.
0.25,
Yeah.
is that right? 0.25?
So you times it by 2 since it's the radius?
There was a question. So do you multiply it by 2 because that's the radius? And what's the answer? The answer is excellent, yes. So the radius equals 0.25 right? Yes? 0.25 meters, is that right? So what's the diameter? What's the diameter?
0.5.
The diameter equals 0.5 meters. Okay? Is that a little bit like Greek on the board? Okay? This is the equation, that's the equation that we used, correct? Yes? This is, I plugged into the equation, yes? I got this as an answer, correct? I made it equal with this. Solve for r, solve for the radius. I get this, correct? 0.25 meters. I want the diameter, so I multiply that by 2, and I get that as the answer. Okay? As you were. Have a great day.